So hello guys and welcome to my channel. Today again I am back with another important numericals on machine designs. And today in this lectures we will discuss the numericals related to the design of transformers. And here the first numericals you can see on the screen. Calculate no load current of a 220/110 volt 1 kVA single phase transformers with the following data. Uniform cross sectional area of the core is given as 25 cm squares and effective magnetic core length given as 0.4 meters and core weight is given as here 8 kg and maximum flux density is given as here 1.2 Tesla. And magnetizing force is given as 200 ampere ton per meters and a specific core loss is given as here 1 watt per kg. So here we have to determine the no load current. So for no load current, here we have the formula as I naught is equals to root under IC square plus IM. So for first we need to calculate the value of IC. So for IC, core loss upon V1, and core loss is calculated as loss per kg into weight of core in kg, and here loss per kg is given as, here you can see the weight of core and loss per kg is given as in the questions. Here core weight is given as 8 kg and a specific core loss is given as here 1 watt per kg. So 1 into 8 upon V1 means primary voltage 220, so you'll get here 0.036 ampere. Now we need to calculate the value of IM, means magnetizing current. So IM is equals to 80 iron plus 8 followed by 50 Lg Bm upon root 2 into T1. So here the value of Lg is not given in the questions as there is no any effect of there is no data on effect of joints, so value of Lg will be 0 here. So if the value of Lg is 0, then this whole term will be omitted here. So 80 iron upon root 2 into T1 will be remaining here. So 80 iron upon root 2 into T1. So here 80 iron will be 8 ampere ton per meter into effective magnetic core length. So 8 ampere ton per meter is given as 200 in the questions, and effective magnetic core length is given as 0.4. So on calculation we will get the 80 iron as 80 here. And now in order to calculate the T1, we have T1 is equal to V1 upon ET. So V1 upon 4.44 F5 and V1 is 220, 4.44 and F is 50, and in place of 5 we can write AI into BM. So 220 upon 4.44 into 50 into, and again in place of AI you can write Ki into AZ here into BM. So 220 upon 4.44 into 50 into, and in place of Ki you can write here 0.9, in place of AZ you can write here 25 into 10 power minus 4, and in place of BM we have 1.2 here. So here all the data are given in the questions, just you need to substitute the values here. So on calculation you will get here the value of T1 as, here we have obtained the value of T1 as 367, and IM will be now ampere. Now IM will be 80 upon root 2 into 367, since if the formula was 80 ampere ton iron upon root 2 into T1, so 80 iron is 80 upon root 2 into T1, in place of T1 we have 367. So this will be equivalent to 0.154 amperes. Now I naught will be IC square plus IM square, and we have obtained the value of IC as 0.036 and value of IM is here 0.154 ampere. We have obtained here value, and here we have already obtained the value of IC as 0.036. This square means IC square plus IM square. So root under IC square plus IM square gives the value of I naught current, that is 0.158 ampere. And here is another design problem. Determine the dimension of core and yoke for a 200 kVA 50 Hz single phase core type transformers. Cruciform core is used with the distance between adjacent limb equal to 1.6 times the width of laminations. Here the adjacent limb equals to, here you can see the distance between adjacent limb equals to 1.6 times the width of core lamination given, and assume the voltage per turn is here, voltage per turn is given as 14 volt, and maximum flux density is 1.1 Wb per meter squares, and window space factor is given as 0.32, and window space factor here we have 0.32. Similarly, current density 3 ampere per mm square, and stacking factor given as 0.9, and the net iron area is 0.56 d square in cruciform core, where d is the diameter of circumscribing circles, and also the width of largest tapping area is 0.85 d. So these are the conditions given in the questions, and with the help of this you have to determine the dimension of core and yoke of a single phase core type transformer. And also one thing, here we have single phase core type transformer is given, so be careful here. So the transformer type may be different here. And here first step is voltage bottom. So for voltage bottom you have 4.44 FIMs and 4.44, and in place of 5 we can add AI into BM, so BM into AI here you have written. Now from this we can calculate the value of AI. So AI will be ET upon 4.44 FIMs, and ampere turn ET value of it is 14 given in the questions, and 4.4 F, and similarly BM is also given as 1.1. So on solving we will get the value of net iron area as 0.0573 753 meter squares. Now, and also the here AI is equals to 0.56 into d squares. This condition is also given in the questions. Here you can see the net iron area. Here net iron area is 0.56 d square. So here we have used this condition. So AI is equals to 0.56 d square, and in order to calculate the d you have AI root under AI upon 0.56, and here we have obtained the value of AI, and here we have substituted the value of AI. So on solving we will get the value of small d as 0.32, and again here you can see the width of, here you can see the width of largest stamping area stamping is 0.85 d. It means the width of largest stamping area, and it is represented by a small a. So a is equals to 0.85 d, so 0.85 into d, and here we have taken value of d as 0.32 into 0.32 gives 0.272 meters. Now again here we have one more condition given in the questions. Here you can see a cruciform core is used with the distance between adjacent limb equals to 1.6 times the width of core laminations. So step by step you can use the condition here, and here the condition is distance between adjacent limb capital D is equals to 1.6 here, and here we have obtained the value of A. So from this here we can use the value of A. So A is 0.272, so 1.6 into in value of A gives 0.435 meters. Now width up into W is going to give capital D minus D, and here we have obtained the value of capital D. This is capital D, and also we have obtained the value of small d. This is small d. So capital D minus small d on subtracting we will get 0.115. And now here in the question this is for single phase core type transformers. So for single phase core type transformer we have the formula Q is equals to 2.22 F Bm Kw del Aw Ai into 10 power minus 3. So from this relation we can calculate the value of Aw. Here the value of Q is given, and similarly F Bm Kw del Aw Aw we need to calculate here, and Ai is also given, so into 10 power minus 3. So on substituting the further value we can calculate the value of Aw as window area as 0.0298 meter square. And here height of window SW is given as AW upon WW, and here we have obtained the value of AW as 0.0298, and WW we have also obtained 0.115. And here I have listed a formula, and here altogether there are 3 conditions here. So in the questions if it is for single phase core type, remember this is for core type, so value of overall height will be S is equals to SW plus 2SY, and W will be D plus A. Similarly for single phase cell type, if it is cell type, then S will be SW plus 2SY and W will be 2WW plus 4A. Similarly for three phase core type, S will be SW plus 2SY and W will be 2D plus A here. So remember this formula and just calculate all the values and substitute here. So here for yoke, depth of yoke dy will be directly the value of a small a, and similar the height of yoke sy will be directly the value of a small a. Now overall width of frames, since this is the case for here, this is the case for single phase core type transformers. This is the case for single phase core type transformer 4. So here single phase core type transformer we have used the value of H as this and similar the value of W as this. So here we can use the overall height of frame will be S is equals to SW plus 2SY, and here we have SW, we have obtained the value of SW as 0.26 and plus 2SY, and in place of SY here we have A, we have used the value of A as 0.272. So on solving we will get the overall height of frame as 0.804 meters. Similarly the overall length of frame W will be D, capital D plus A, and here we have also obtained the value of capital D, and here we have obtained the value of A as here we have obtained the capital value of capital D and small a. Here you can see we have obtained the value of D A. Just you need to remember the formula and apply it. So finally we will get the overall length of frame as 0.737 meters. Now let's see another important numericals, and this is also frequently asked numericals. So here calculate approximate overall dimension for a 200 kVA 6600/440 volt 50 Hz 3-phase core type transformers, and the following data may be assumed. An EMF pattern is 10 volt given, and maximum flux density is 1.3 Wb per meter square. Current density given as 2.5 ampere per mm square. Window space factor given as 0.3, and here overall height is equals to overall width, means S is equals to W, and the stacking factor is given as 0.9, and here we have to use a three-stepped core. And for a 3-step core, the data is given as here the width of largest stamping area is 0.9 d, and the net iron area is 0.6 d square, where d is the diameter of the circumscribing circles. So here starting with the solutions. So net iron area is given as A is equals to ET upon 4.44 into F bms. So ET is 10 given, and 4.44 into F, and F is frequency is 50, and BM is also given as 1.3. Here all the data is given in the questions. You can see here EMF pattern is 10 given, flux density given, current density given, all the data are here. So here net iron area will be 0.0347 meter square. Now net iron area, here the condition is given as here you can see the net iron area is 0.60 d square, and here we have obtained the value of AI. With the use of this we can calculate the value of a small d. So small d will be root under AI upon 0.6. So and it is going to give 0.24 meters. And now the width of largest stamping area is given as A is equals to, this is also given in the questions, as this is also one of the condition. So A is equals to 0.9 d. So 0.9 into d, you have obtained just value of d. So just use it, 0.24 will get the value of small a as 0.216 meters. Now using a 3-step section for yoke, height of yoke SY will be directly the value of A here, and the depth of yoke DY will be directly the value of A. So these two value will be same, and that is 0.216 meters. Now this is for 3-phase core type transformers. So for 3-phase core type transformer, value of Q will be 3.33 F BM KW del AWAI into 10 power minus 3. So from here we can calculate the value of AW here. All the parameters are given in the questions. Just substitute all the values and obtain the value of AW here. So window area will be 0.0355 meter square. Now height of window SW will be AW upon WW, and AW is given as 0.0355 meter squares, and WW, so here this is equation 1. So WW is unknown here. So let it as a equation 1, and also the overall height is equals to overall width given in the questions here. Here you can see here the overall height of the height is equals to overall width given in the questions. It means S is equals to W. Now for 3-phase core type transformers, we will use the condition for 3-phase core type transformer. Overall height is equals to overall width, S is equals to W. Here we have, so here H will be SW plus 2SY and SW plus 2SY, and 2 into in place of SY we have A. So SW plus 0.432 and W will be 2D plus A. So in place of D we can write WW plus D plus A and 2WW plus 2D plus A and 2W plus D, and we have obtained the value of D and A. So we'll substitute the value of D and A. So 2WW plus 0.48 plus 216. So 2WW plus 0.696. And since we have the given condition as S is equals to W, so we will equate these. So S is equals to W, these two value. So here SW plus 0.3 and plus 2WW plus this value. So SW equals to 2WW plus 0.264. And here in place of SW we can use 0.0355 upon WW. Here we have used the equation 1. So in place of SW we can use this value. We have used this value 0.0355 upon WW. So using here equation 1, we have substituted the value of SW here. So 0. And now we have WWWW. So from this we can obtain the value of W. And this is the quantity equation 2W square plus 0.26 for WW minus 0.355. So we'll get the value of WW as 0.83 meters. Now using 1 we can write here SW equals AW plus AW upon WW. So AW have obtained and WW here just now we have obtained the value of WW. So SW will be 0.428 meters. Now the dimension of core R, distance between S and core D will be WW plus D, and overall height will be S is equals to SW plus 2SY. Similarly overall width will be 2D plus A, and that will be 0.862 meters. So here this was our final answers. Hope you enjoyed the lecture. Thanks for watching, and please don't forget to subscribe to my channel. Thank you.